Transient effect of aircraft propeller blade by using composites. Abstract: a propeller is a type of fan that transmits power by converting rotational motion into thrust. A pressure difference is produced between the forward and rear surfaces of the airfoil-shaped blade, and a fluid, such as air, is accelerated behind the blade. Propeller dynamics can be modeled by both Bernoulli's principle and Newton's third law. Aircraft propeller is sometimes colloquially known as an air screw propeller. The present work is directed towards the study of composite aircraft propeller working, and its terminology, simulation, and flow simulation of composite aircraft propeller has been performed. To analyze the composite aircraft propeller in ANSYS software. Static and dynamic analysis is to determine the deformation, stress, and strain of the composite aircraft propeller blade. Fatigue analysis to estimate the life of the component. The optimizing the propeller blades, varying the No of blades 2, 3 and 5 blades, and also optimizing the material glass epoxy, aluminum alloy, and carbon epoxy. 3D modeling done in Kasha parametric software. Aircraft. An aircraft is a machine that is able to fly by gaining support from the air. It counters the force of gravity by using either static lift or by using the dynamic lift of an airfoil, or in a few cases the downward thrust from engines. Common examples of aircraft include airplanes, helicopters, airships, including blimps, gliders, parameters, and hot air. The human activity that surrounds aircraft is called aviation. The science of aviation, including designing and building aircraft, is called aeronautics. Crewed aircraft are flown by an onboard pilot, but unmanned aerial vehicles may be remotely controlled or self-controlled by onboard computers. Aircraft may be classified by different criteria, such as lift type, aircraft propulsion, usage, and others. Related image. Figure 1.1 Aircraft. Propeller aircraft. Propeller aircraft use one or more propellers, air screws, to create thrust in a forward direction. The propeller is usually mounted in front of the power source in tractor configuration, but can be mounted behind in pusher configuration. Variations of propeller layout include contra-rotating propellers and duct fans. Propeller blade. Thrust is the force that moves the aircraft through the air. Propeller blade. Thrust is the force that moves the aircraft through the air. Description. Blade face is the surface of the propeller blade that corresponds to the lower surface of an airfoil or flat side, we called blade face. Literature review. Y.S. Rao and B.S. Reddy 1 shows composite propeller blades are safe in case of resonance phenomena in their harmonic analysis. Vibration defect can also be controlled in case of composite, as damping effect is more. They had done a comparison of harmonic analysis using ANSYS software between aluminium metal and S2 glass fabric/epoxy. From their result, maximum displacement in case of composite is 0.08192, which very less than aluminium propeller blade 0.1784. M.A. Khan et al. 2 observed interlaminar shear stress for composite material considering different No of layer and shows there is strong bonding between the layers. Eigenvalue analysis shows composite material has 80.5% more natural frequency than aluminium propeller. In their static analysis they had shown composite consist of separate layer. V. Gunesh et al. 3 had done static and modal analysis for aluminium propeller and composite, carbon-reinforced plastics, propeller. From their analysis it shows blade deflection in case composite propeller is very less compared to aluminium. Besides that, they also observed the stress-strain variation for the strength analysis. Introduction to CAD. Computer-aided design, CAD, is the use of computer systems, or workstations, to aid in the creation, modification, analysis, or optimization of a design. CAD software is used to increase the productivity of the designer, improve the quality of design, improve communications through documentation, and to create a database for manufacturing. CAD output is often in the form of electronic files for print, machining, or other manufacturing operations. The term CAD, for computer-aided design and drafting, is also used. Introduction to Kasha. Kasha is an acronym for Computer-Aided Three-Dimensional Interactive Application. It is one of the leading 3D software used by organizations in multiple industries ranging from aerospace, automobile to consumer products. Kasha is a multi-platform 3D software suite developed by Dassault Systems, encompassing CAD, CAM as well as CAE. Dassault is a French engineering giant active in the field of aviation, 3D design, 3D digital mock UPS, and product lifecycle management, POM, software. Kasha is a solid modeling tool that unites the 3D parametric features with 2D tools and also addresses every design to manufacturing process. In addition to creating solid models and assemblies, Kasha also provides generating orthographic, section, auxiliary, isometric or detailed 2D drawing views. It is also possible to generate model dimensions and create reference dimensions in the drawing views. The bidirectionally associative property of Kasha ensures that the modifications made in the model are reflected in the drawing views and vice versa. General characteristics. Crew, none. Capacity, 68 kg 150 pounds payload. Length, 5.85 m, 19 feet 2 in. Wingspan, 8.54 m, 28 feet 0 in. Height, 1.25 m, 4 feet 1 in. Gross weight, 500 kg 1,100 pounds. Airfoil, NACA 64A008. Power plant, 1 times Limbach L550, 40 kilowatts, 47 HP. Performance. Maximum speed, 8,000 RPM. Endurance, 18 hours. Service ceiling, 6,100 meters 20,000 feet. Design specifications. Case 1, aircraft propeller with 2 blades. Case 2, aircraft propeller with 3 blades. Case 3, aircraft propeller with 5 blades. Introduction to FIA. Finite element analysis is a method of solving, usually approximately, certain problems in engineering and science. It is used mainly for problems for which no exact solution, expressible in some mathematical form, is available. As such, it is a numerical rather than an analytical method. Methods of this type are needed because analytical methods cannot cope with the real, complicated problems that are met with in engineering. For example, engineering strength of materials or the mathematical theory of elasticity can be used to calculate analytically the stresses and strains in a bent beam, but neither will be very successful in finding out what is happening in part of a car suspension system during cornering. Structural analysis. ANSYS Autodin is computer simulation tool for simulating the response of materials to short-duration severe loadings from impact, high pressure, or explosions. ANSYS Mechanical. ANSYS Mechanical is a finite element analysis tool for structural analysis, including linear, nonlinear and dynamic studies. This computer simulation product provides finite elements to model behavior, and supports material models and equation solvers for a wide range of mechanical design problems. ANSYS Mechanical also includes thermal analysis and coupled physics capabilities involving acoustics, piezoelectric, thermal, structural and thermoelectric analysis. Static analysis of aircraft propeller blade. Aluminum alloy. Carbon epoxy. E-glass epoxy. Case 1, aircraft propeller with 2 blades. Imported model. Meshed model. Boundary conditions. Material carbon epoxy deformation. Stress. Strain. Material carbon epoxy. Deformation. Stress. Strain. Material carbon epoxy. Deformation. Stress. Strain. At time 10 SEC. Deformation. Stress. Strain. At time 20 SEC. Deformation. Stress. Strain. Material aluminum alloy. At time 10 SEC. Deformation. Stress. Strain. At time 20 SEC. Deformation. Stress. Strain. Static analysis table. Conclusion. The present work is directed towards the study of composite aircraft propeller working and its terminology, simulation, and flow simulation of composite aircraft propeller has been performed. To analyze the composite aircraft propeller in ANSYS software. Static and dynamic analysis is to determine the deformation, stress, and strain of the composite aircraft propeller blade. Fatigue analysis to estimate the life of the component. The optimized the propeller blades varying the No of blades 2, 3 and 5 blades and also optimized the material E-glass epoxy, aluminum alloy and carbon epoxy. 3D modeling done in Kasha parametric software. By observing the static analysis results, the less stress has 5 blades propeller compare with 2 blades and 3 blades, and comparison between materials, the less stress has carbon epoxy material than E-glass epoxy and aluminum alloy. By observing the fatigue analysis results, the more safety factor has 5 blades propeller compare with 2 blades and 3 blades, and comparison between materials, the less safety factor has carbon epoxy material than E-glass epoxy and aluminum alloy. By observing the dynamic analysis results, the less stress has 5 blades propeller compare with 2 blades and 3 blades, and comparison between materials, the less stress has carbon epoxy material than e-glass epoxy and aluminum alloy. So it can be concluded the aircraft propeller with 5 blades and carbon epoxy material is the better.